Assalamu alaikum everyone. I am Tanzila Akter from Group 14. My other teammates are Shakib, Mahmud, Ayon and Pritom Saha. Our assigned project is body powered prosthetic hand. I will describe our project motivation, problem statement and specific aim or objective. Pritom will describe design of the project, performance evaluation and discussion. And lastly, Ayon will take over rest of the presentation. We get motivation from here that according to World Health Organization, about 30 million people need limb amputation per year. So, limb amputation is a common phenomenon in this industrial age, but the current available model is very costly, which is out of financial capability of different countries like ours. Current body-powered prosthetic hand has lots of joints, especially in the finger area, which create a lot of friction than normal hand. Also, current model mainly focused on showcasing state-of-the-art rather than affordable price. Our main objective or aim in our project is to make a low-cost body-powered prosthetic. In that case, a prosthetic hand. As our prosthetic is body-powered, so we are focusing only on functionality, that is gripping. As we have discussed, the main problem in the previous slide is the friction present in the available models. For this, it requires great effort to perform even the simplest of movement. So our objective is to reduce the friction to an optimum level. My next teammate, Pritom, will continue the presentation from here.
This is the design of our project when all parts are fully assembled. Our project consists of three basic parts. They are fingers, palm, and forearm. All parts are designed with dimension of human hand. So, all 5 fingers are different in size. We have made all the parts hollow design to reduce the mass of the all parts. We wish to control the finger movement with non-elastic wires or threads. So, we made the channels for threads. We have made restriction on all parts to restrict the unwanted rotation. This is the design of our shoulder connector. This part connects the prosthetic to the shoulder where the movement of the finger will be initiated. This is the gripping motion using SolidWorks motion study. In the animation, we can see a wire being pulled by which the fingers are being connected. This wire going to get connected to the shoulder connector. In this way, we will be drawing effort from the movement of the shoulder. Using the shoulder movement, the wire will be pulled and that will close the flow of the hand and completing the grip motion. This is the ANSYS analysis for total deformation simulation of our design. This deformation simulation is done for when the hand is gripping a 5 kg object. For this simulation, the boundary conditions are the elbow joint and the wrist joint is fixed support and a downward force in the palm is considered. This is the deformation graph of our ANSYS simulation. In the graph, the red line shows the minimum deformation, blue line shows the average deformation, and the green line shows the maximum deformation. The rest of the parts will be described by our next teammate, Shakib Mahmud.
In this picture, we can see how the prosthetic and the shoulder connector will be connected to a patient. As a human hand has lots of joints and all the joints can be moved. To move each single joint of the prosthetic with efforts drawn from the body movement is very difficult. So we have decided to work with only one motion, gripping. The prosthetic can be produced 3D by using light materials like carbon fiber. We have started off our designing with some simple references. But after all the modifications, we have come up with some novel parts in our design. In the fingers, we have excluded the distal interphalangeal joints and only included metacarpophalangeal joints and proximal interphalangeal joints. Reducing the joints will reduce the chances of unnecessary rotatory movements and also reduce the friction of the wire. For the thumb design, we had to consider the movement of the thumb in the lateral direction of the palm, because of which the angle of the wire will be acute and the friction will be great. So we decided to reduce the angle of the wire by passing it through the farthest channel. Shoulder connector will be connected to the prosthetic with the patient's body. It will also draw motion from the shoulder and channel it to the wire to pull the fingers and grab an object. Pros. As promised, we have come up with a design with reduced friction. We obtained this by excluding few joint movements and also excluding distal interphalangeal joints in the fingers. We took reference from an available model as well as human hand, and the dimensions are also taken from regular human hand. So the prosthetic will look the closest to natural. We have also cut down expenses by excluding functionalities and also choosing low-cost materials. The entire functionality of the prosthetic is in theory right now. So we will need to materialize it to actually test the functionality. We have considered some of the joints to be fixed, so the prosthetic will not be able to perform some other basic movements where there are wrist movements included. The entire project is done in software. So we don't know some of the real life problems we may face while manufacturing the prosthetic. So if it is possible in the future, we would like to work to manufacture this project. And if further studies can be done on this, our recommendation would be to study about the human hand, hand movements, and muscle properties. Minimize friction while allowing all the joints to be mobile. Study more about the thumb and come up with the best possible outcome where the wire angle can be optimum. Thank you very much. If you have any questions, please ask.